Hi, this is Wendy, and in this video series, we're looking at selections or if statements. In the first video, we looked at single and double-sided selections. In the second video, we learned about multi-selections and the switch statement. In the previous video, we saw how nested selections work, and in this last video, we'll look at some common errors that programmers often make with selections and how to avoid them. If you go to chapter 3.6 of your text, you'll see that they go over some common errors and pitfalls with selections. In fact, later in this course, and even in Java 2, I will often refer you back to this chapter when I see something being done incorrectly. So bookmark this chapter and take notes on it so that you don't forget the content. Now, some of these things we've already discussed in previous videos, but some of these are also new, so let's go over each one. The first common error they mention is one that we have talked about several times in previous videos, and that's forgetting necessary braces. Remember that if you leave off the braces, only the first line of code in a block is considered part of that block. So here, only the area equals radius times pi is actually part of the if block or inside the if block. This print line is after the if, so it will be executed regardless of whether radius greater than 0 is true or false. It's basically just not indented correctly. This is the correct way to actually write this code, is just by adding the braces around it. This is why I nag you all the time to leave the braces on, so that you can avoid making this error by mistake. The second common error is putting the semicolon at the end of the if header by mistake, such as you see in this example. I'll actually show you a different one in the editor, because I've got one where the error is actually harder to spot if you're not looking for it. So here I have a variable number that's defined as an int and initialized to 0, and I have an if statement that says if number is greater than 1, then it will print out foo. When I look at the expression number greater than 1, I see right away that this is going to be false, so we would think that it's going to skip over the foo and not print anything at all. However, when we save, compile, and execute the program, we see that it in fact does print the word foo on the screen. The reason is because there's a semicolon after the if header, if number greater than 1, and then there's a semicolon on the end. This will treat the if number greater than 1 as a single statement. It will actually evaluate number greater than 1, but then that's the end of the if statement. It basically creates an if block with no code body or no code to execute if the condition is true. It assumes that the print line is actually after the if statement, so it executes regardless. If you add braces to the if statement, it actually doesn't matter. You might think the braces tell Java that this is an if block, but it doesn't. In fact, it's okay to have a set of braces in the middle of your code like that. It's not a common thing to do, but it is allowed. So this block of code here is actually equivalent to this block of code. So I'm declaring number, I'm evaluating the number greater than 1, but then there's no code body inside the if, and then the print line foo is after. These two blocks of code are logically exactly the same. This code segment is an example of a logic error. The program compiles, it runs without crashing, but it doesn't do what it's supposed to do. It doesn't produce the output that you think it should. Later, you'll learn about looping, and you'll notice that you can actually make this same mistake with looping as well. Now, common error number 3, redundant testing of Boolean values, is another one that you've heard me mention in previous videos. Here, it's redundant to test the Boolean variable even to see if it's true. You don't need to create a Boolean expression here because even is already a Boolean variable. I mean, we can't see that it's declared as a Boolean, but obviously if they've got it in an expression like this one, you can't, for example, compare an int to the Boolean value true, so even must be a Boolean variable. So this is actually redundant. You don't need to convert this into a Boolean expression. The even on its own already is true or false. So if you click on the B button, this is the correct and more efficient way to do this. All you need to do is just put the variable name even. So remember, If this expression in the brackets yields true or false, it's a Boolean. So even is already true or false. There's no need to add extra operators to this expression to make it Boolean. It's already Boolean. In fact, adding the double equals true means that you're giving your program an extra operation to perform, which can slow down your program. Also, note that if you accidentally use the assignment operator instead of the double equals operator, it's treating this as an assignment statement. Assignment statements also return a value. Generally, it's the value of the data in the assignment statement. So if you were saying the integer variable x is assigned the int literal 5, that assignment statement would return an int. Of course, putting x single equals 5 inside an if like this one would mean that your program doesn't compile. It would tell you that that's not the correct type of data for an if expression. However, here, and I just created a variable even and just assigned it a random Boolean expression. But here, even is a Boolean and true is a Boolean, so accidentally assigning the value true to even results in a Boolean expression. This means that your program will actually compile and it will run without crashing, and it prints the value even, but that's actually because this assignment statement will always yield the value true, so this will never ever be false. Here I'm assigning 5 modulus 2 double equals 0. That's basically saying, is 5 an even number? So 5 modulus 2 is going to be 1, which is not equal to 0. So the variable even is in fact false, but you see that here this is evaluating as true because it's an assignment statement and not a relational or logical expression. So this is actually another kind of logic error. So there's 2 good reasons to make sure that you don't use extra operators on things that are already Boolean to begin with. So this would be the correct way to write this expression. If I save, compile, and execute this program, I get no output at all, which is what I should actually see. Again, the variable even has been assigned a value of false because 5 modulus 2 is not equal to 0. So when it sees that this is false, it skips and there's no else block. It skips this code and the program ends. Another common error we've talked about is this one in number 4, dangling else ambiguity. Recall that when you leave off the braces, an else always belongs to the if immediately above it. So here in this example, we have nested ifs. There's an if I greater than j with a nested if I greater than k. And because of indentation, it looks like the else belongs to this, to this if up at the top, but it actually doesn't. Because there's no braces, this else actually belongs to this if. It's equivalent to writing the code this way. So this is the code written with the proper indentation. So there's really no else block to this outer or this first if statement. As we saw in a previous video, you can make this else belong to the first if simply by adding braces to the right location in your code. Common error number 5 talks about equality test of 2 floating point values. In an earlier video, we talked about floating point approximation. Recall we had code similar to this one that displayed a really strange value for x. We would expect that we would see 1.0 minus 0.1 5 times would give us 0.5, but in fact it gives us 0.5, a bunch of zeros with a 1 on the end. And we talked about that. That's because of floating point approximation. That means then, if you add a statement like this one, where I ask, is x exactly equal to 0.5, that we would think would print true just looking at the code, but in fact, it prints false because x is not exactly equal to 0.5. We can actually see that here. Now they have a pretty ugly solution to this problem in the text right there. But usually you won't often need to compare floating point numbers for equality. You'll generally use inequalities like greater than or equal to, less than or equal to. Pitfalls are mistakes that programmers often make without realizing it, and they might not necessarily make your program malfunction, but they definitely affect the efficiency of your code. This first one has to do with simplifying Boolean variable assignment. This is also something we've talked about in previous videos. The problem with this if statement is that it's not necessary. In fact, having an if statement where you don't need one is just adding extra work or processing to your program. This is sometimes why some applications are slower than others that do similar tasks. The slower one might have a lot of inefficient and unnecessary code, like this one. Here we have if number modulus 2 double equals 0, and then it's assigning the value true to even, otherwise it's assigning false to even. It's completely unnecessary to waste processing by using an if statement. If you click on the B button, this is actually the more efficient way to write this expression. This is already Boolean, so it will evaluate to either true or false, and that will be stored in the variable even. It's not necessary to do this with an if statement because, again, this is going to be evaluated to either true or false, so why bother explicitly assigning true or false to even when you can write it this way? So the second way here is actually better. This is also true of the conditional operator. This statement here is also redundant and it's a waste of processing. The conditional takes up processing time just like an if statement does. So this is also completely unnecessary. We are actually evaluating this expression to true or false and then going to the extra trouble of saying, okay, if this is true, return true, else return false. This is totally unnecessary. Again, all you need to do is just simply write Boolean even equals number modulus 2 double equals 0. That's all you need. The second version of this statement is way more efficient than the first version. Now, if the purpose of the code was to print strings, even or odd, then the if statement or the conditional would be fine. For example, if I had a string str even equals and then have number modulus 2 equals 0, then return even or odd, then that's fine because it's returning a string. But if your expression is to return a Boolean, then you don't need an if or a conditional because it's the expression that you're comparing is already Boolean. A lot of people don't realize how important it is to have efficient code. Again, it can slow down a program considerably. I'm sure you've experienced this yourself by using software that is not well written. It's not just about memorizing code and writing statements. It's about writing code that's efficient. Especially for you guys, because you guys are going to be doing most of your programming on small mobile devices, and that's where you have limited resources. So the efficiency is actually going to be a huge deal on those kinds of devices. A slower program is going to seem a lot slower on a smaller device. This second pitfall is about having duplicate code in different cases of any kind of selection structure. This is another one of those things that I've mentioned before. It's important to try and reduce the amount of redundant code in your program because redundant code takes more time to modify or debug and it's more prone to errors. For example, if your client wanted to change how the output appeared in this example, then you'd have to change 2 statements instead of writing it correctly where you could only change 1 statement. If we look at this code in a little more detail, we can see we have, again, this is the proper way to test a Boolean variable in an if statement. So we have if, and they're comparing in state, they assign a value to tuition and then output the tuition. And then in the else block, they're assigning a different value for tuition, but then they're printing the exact same output using the tuition variable. This print line statement is redundant. So if someone wanted to modify how the tuition was output, maybe they want to format it, you'd have to remember to edit both of these statements. Now, this doesn't seem like a big deal right now, but imagine you had several if, else, if, else, if, else, if blocks. That's where you're going to accidentally make mistakes. This is the proper way to write this code. And notice also we assign, we don't calculate either. If we had a calculation to perform, we would do that down here with the print line. Again, you've seen me do this before in previous videos. Now there's one more thing I want to show you that's not mentioned here in chapter 3.6, and it has to do with something called variable scope. Variable scope defines the accessibility or visibility of variables. Now, so far, this isn't something that we've had to think about because we declare and use all of our variables inside the main method of our program. However, as we now start to use more complex program structures, and later when we learn methods, we'll see that we can actually declare variables that are accessible or visible in some parts of our program, but not other parts of our program. So let's try a simple example so we can understand this better. So I've created a variable called balance, and then I have a very simple if statement that checks the value of balance. If the balance is 1,000 or more, I assign 2 to the rate variable. Otherwise, I assign 1.2 to the rate variable. And then after the if statement, I calculate a total as rate times balance, and then I print that total. Now, if you save and compile this program, you're going to see an error in your output console. So here it says error cannot find symbol, and it's pointing to the rate variable in the statement where I declare total and then try to calculate rate times balance. So does this make sense? I mean, I defined rate on lines 18 and 20, so why does Java think that rate is undefined? This is actually a problem with the scope of the rate variable. The rule is that when you declare a variable inside a block or inside a set of braces, the variable is only accessible or visible inside that block or inside those braces. In other words, you can only use the variable inside the block where it is defined. So here I am defining rate inside the if block. So that means the rate variable is only accessible or visible inside that if block. Even if I remove the braces, it's still an if block and the variable can only be used inside the if block. Similarly, I'm defining a different rate variable inside the else block, so that rate variable is only available inside that else block. Now, you probably know from past mistakes that you can't declare the same variable twice, but this is a weird situation because, in fact, these are two different rate variables. They are different variables in memory. They are stored at two different locations. Since the first rate is only visible inside the if block, and the second rate is only visible inside the else block, neither variable can see each other. Imagine that you were at home and one of your relatives, your siblings, or your parents, or your kids, was in another room and you had no windows. While they're in that room, you can't see them or access them while they're in that room. They would have to leave that room, and then you would have to leave your room and meet up in the hallway, for example. This is what's happening with these two variables. They are sitting in their own rooms and they cannot see each other. In other words, they have two different levels of scope. The first rate variable scope is limited to the if block, and the second rate variable scope is limited to the else block. This means neither rate variable is accessible or visible to this statement double total equals rate times balance. They're only visible inside each of their own blocks. They're not visible outside of the blocks. So if your relative was in the room with the door closed and you were out in the hallway, you can't access them unless you go into the room or they come out of the room. Another word that we use often when we're describing this situation with variables is the word local. So we would say that the first variable is local to the if block and the second rate variable is local to the else block. Now, to fix this problem, we simply increase the level of scope. So again, if your relative was enclosed inside a room, you would just coax them to come out of the room into the hallway where you are, thus increasing their level of scope so that you have access to each other. And this is what we do. What we do first is we need to declare the variable rate somewhere so that it can be accessed by both the if and the else blocks inside them, but also by this statement inside the main method. So we declare our variable really at the same level where we declare balance. And we can assign it a 0 to start off with. Now we have to take off the declaration part of these two statements, otherwise we're going to get yet a different kind of error, so we don't want to do that. And that's all we need to do. Let me just move this down a little bit here. So we've increased the level of scope. So now rate has main method scope. Let me just do this. So we've now increased the scope of the rate variable to the main method. It is now local to the main method. That means that it's available anywhere inside the main method. Inside the if, inside the else, and outside the if and else as well. Again, when you declare a variable inside a block or inside a set of braces, it's accessible or visible anywhere inside that block. And so because balance and rate are both declared inside the main method block, they are available anywhere inside the main method block. If we save and compile, we'll see that it now compiles successfully. And I guess we could run it if we wanted to. It doesn't really matter. It's going to run anyways. This idea of scope applies to any block. If block, else if blocks, a block inside a switch statement. Remember, a switch statement has one big block. And later we'll see this also applies to loops. And then even later than that, our own methods that we end up writing as well. So those are some of the common errors and problems that you'll encounter when working with selection statements and Boolean expressions. Make sure you try the self-check and freestyle exercises at the end of chapter 3.6. I do often steal those and put them on quizzes and exams. And make sure you do all of the recommended practice exercises in the notes, and it wouldn't hurt to do some of the extra ones as well. If you need more practice, just ask. That's it for this video series on selection statements, and in the next set of videos coming up, we'll continue our discussion of program structures by looking at iteration. Thanks for watching.